In this video, I'll help you unlock the math skill, perimeter of part of a circle. My secret is showing you 3 keys that break down the critical information on this skill. We're exploring the length workshop, where every measuring instrument unlocks a new math skill. We've already covered these foundational lessons, and now we're tackling the lesson, perimeter of part of a circle. In this section, you will learn where this skill is used in the real world. Have you ever watched a 200-meter sprint race in the Olympics and noticed something strange? The runners in the outside lanes start way ahead of everyone else. It looks like lane 9 is getting a massive head start, right? I mean, look how far in front they are. But here's the question, is that fair? If lane 9 starts further ahead, do they actually run the same distance as lane 2? How do officials make sure every single runner travels the same distance? Remember, they can't just eyeball it. This is the Olympics. If someone runs even 1 meter extra, the race is ruined. That curved section is part of a circle, and the total distance around a circle has that special name, the circumference. If we calculate the circumference accurately, we will then be able to calculate each lane's distance. However, it doesn't just stop there. We can apply this to every other real-life object that makes up part of a circle. In this section, you will learn how to find the perimeter of a semicircle and how to find the perimeter of a quadrant. What is the formulas used to calculate the circumference of a full circle? Here is a quick reminder, the 2 versions of the same formula are pi times the diameter and 2 times pi times the radius. Both are the same idea since 2 lots of the radius is the same as the diameter. Knowing the formula for a full circle is the critical piece needed to master this new skill. However, students still get stuck once they see a different shape like a semicircle or quadrant. They think these new shapes need an entirely new formula. However, it's easier than what you may expect. Let's start with the semicircle. If we want to find the perimeter, there are 2 measurements that make up the total distance around the shape. 1 the diameter, and 2 half of the circumference. The diameter is already given, which is 15 in this question. So the only challenge is the arc length, that curved top. To find the arc length, we use the full circle formula. Notice if we leave it here, we have found more than the arc. To find the required arc length, we multiply by the fraction of the circle you have compared to a full circle. In this case, we have 1/2 of a circle. You could also divide by 2. Multiplying by 1/2 is the same as dividing by 2. Now replace D in the formula with 15. Then get your calculator out to help calculate. Running to 1 decimal place, we get an answer of 38.6 centimeters. Now let's look at the quadrant. In total, there are 3 measurements making up its perimeter. We have a radius, plus another radius, plus the arc of a quadrant. And a quadrant is 1/4 of a full circle. So again, start with the full circle formula, then multiply by the fraction of the circle you have. In this case, 1/4. Now replace r in the formula with the radius 5. Then use the calculator to help calculate everything, giving an answer of 17.9 centimeters rounded to 1 decimal place. So that's the key piece of information. You don't need an entirely new formula. You just need to make simple adjustments to the same formula, just based on how much of the circle you're working with. In this section, you will learn how to find the perimeter of a sector and discover the most common student mistake. We've done half a circle and a quarter, But what happens when the slice isn't neat? When the angle could be anything? This is the moment most students freeze. They don't know the fraction needed to multiply the full circumference formula. Let's break it down. A sector's perimeter is still made up of the same parts as before. 2 straight radii plus the arc. How many degrees makes up a full revolution of a circle? Yes, a full circle is 360 degrees. That becomes the denominator. The numerator is the angle of the sector. In other words, how many degrees of a complete circle you have. For this example, 75 degrees. So to find the perimeter, add both radii and multiply the full circle formula by the fraction 75 over 360. Replace r in the formula with the radius 4, using a calculator to calculate, giving an answer of 13.2 centimeters rounded to 1 decimal place. This is the formula for the arc length of any part of a circle. The fraction of the amount of the circle you have times the circumference formula of a full circle. We write the fraction with denominator 360, and the numerator we use the Greek symbol theta. This symbol represents the interior angle of the sector. Here's the final warning, the most common student mistake. Here's where students lose marks. Let me highlight this mistake so that you can avoid it. The mistake is that they obsess over the arc length and they completely forget to add the other sides of the shape. Remember, perimeter means the total distance around the shape. So here's a simple trick. Write in the other side lengths in your working from the start. That way you can't forget them and you guarantee full marks. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.